let's do some check. Did the stream started? Maybe, maybe not. I can't see. Yep, it started. That's good. So, Ranak everybody, you are on the FEArytales channel, and today we will try to create the fine mesh for this model. It was created by one of my students about 13 years ago, so he now is not a student. But, as someone say, if you're a teacher, all student, even X, are your students. So let's try to work with that. Okay. I planned this stream for a long time, but it needed more preparation, so I plan it, but doesn't start. And today, unfortunately, in reason of a very unpleasant night, in reason of our dump neighbor country, I doesn't have any mood. I even can't normally typing on a keyboard. I can't work, so let's try to do something which is not need a lot of the brain resources. I understand that it can look very strange, that I say we will try to create the good hexa-core mesh for this complex object, but all this complex object mostly consists from the part which is not very complex in geometry, and so it can be split in a very simple way. So I think that it will be not very difficult. I don't try it before, so sorry if I will have some problem, but we will try. So here on the grab cards you can download this model with the SAP format. Unfortunately, this SLD-PRT, it's not original file. It's only the same step file, but imported in solid. So he doesn't upload the original file that he created. But for our task, it's not a problem, because it's enough to repeat everything which we do. So we will use the Ansys workbench and Ansys mechanical for creating mesh, and we will use the Ansys discovery, or you can use Ansys space claim. It's very similar by the features, by the principles of modeling and geometry preparation. So we will use this one. Firstly, let's try to take a look on original geometry. I have additionally not the step but per solid format, but it's not the big difference between everything which we do. The Parasolid have some additional benefits in reasons that Ansys Mechanical and Ansys Discovery use the geometry kernel Parasolid, so it can be imported with less errors and so on. But in fact, it's not principle. So, first of all, we will take a look to this model in Ansys Mechanical, and we try to create the automatic mesh for wall assembly, and then we will start the editing geometry. We will split our objects. Some of this object will be splitted on the fine way for very small pieces. Which is where every of these pieces is something like a hexa by itself, and then we also try to use different type of mesh option to this geometry to see how Ansys can create the hexa-core mesh for this object by itself. So license manager is delayed in response. Why? I know that I have limited in time license, but why I have some delayed options? Okay, so it's a very big model. It's about 300 of components. So it needs to take some time to import and so on. But we will start. Yep, some errors with the JavaScript. Unfortunately, it was started when my previous license has ended, and then why I have a problem with Ansys license? Just a moment. License manager. Determining the license manager status. So everything looks fine. Everything is look fine. So this is our model, and as you can see, it has a lot of parts. Mostly those parts are the same, so I hope I don't need to split every of this part. Some of these parts have some difficulties and complexness in geometry, but we will take a look how it will work. So we will do some simplification. For example, we will delete some of these fillets because it's not very important in our modeling, and it can be analyzing if it needs with the sub-modeling of some elements. And if we don't suppress it, we will have the very highly detailed mesh with the very big number of the nodes and elements, and it will be the very big problem for create computational task. But let's try to do it. So first of all, as I say, we will try to create automatic mesh, fully automatic, without any options, even without change the default size of element, you can see that full size of this F1 bolide, it's about half a meter. As I can see, it's very huge model, and in reason that most objects are tiny in size, and in section the default element size is about half of millimeter. So let's try to do automatic mesh, and during this mesh let's open our Ansys discovery, which also needs some time, so we do it in parallel, and we will open this model in Ansys discovery to the editing. Additionally, you can see on the workbench screen that I have two systems, one which I now open with the full model, and the second doesn't have any geometry for now, and it will be used in the strange way. We will check some Ansys feature and some splitting options with this second object. So we open another discovery. We will take some geometry. We'll put this geometry on the new system, do some changes, and then we take a look how the Ansys mechanical will work with those geometry, do it create the fine mesh, do it create the hexa-core mesh, or we need something else. So I see that we have some number of viewers. I will be very glad if you write something on the chat. For example, is the picture is normal? Does the sound is normal? Because I can't check it by myself, even with my fluffy helper, which is now present. So, in reason of the big and complex object, the meshing takes some time. You can see the size of the model, but in the general, if you work with the big objects with some structural construction and so on, you will have the same type of the problem. So you will have a lot of objects, and some of this object will be duplicated in the model, and the whole number of this object are very huge. Some of these objects need to be deleted from the model because it doesn't give any additional useful information for the behavior of modeling in most cases, and we need to do it like with imprints, like with some embosses, with some small fillets, holes, and so on. And it will not affect the behavior of our modeling, finite element modeling and finite element analysis, so it can be done. So in general, the whole process will be the same, and the main type of approaches will be very similar. So I think and want to, so that this stream can be helpful for many of you. I'm sorry that I'm even more slow in some reasons that in most of my video. It's not only because it's stream and I do it without preparation, but it's because today it was about 50 explosions and 50 strikes with drones, rockets and avia bombs during the whole night in my city, because our neighbor terroristic state, so-called Russia, I don't want to say anything, any characteristic, because I think YouTube will ban me. So, unfortunately, I have some difficulties in mood, and I have some slowings. About 15 minutes ago, Russia also struck the Kharkiv, and even we have killed people. So this is our reality. And even if with the noise reduction filter you will have some strange sound on the background, it can be new sound of explosion, unfortunately. So I can't guarantee the result, not only because it's very big and complex geometry, but in any type of circumstances can be lost. The power and electricity, can be lost internet connection, can be lost anything and everything. This is our reality. So the 50% of mesh is already complete. Unfortunately, maybe I don't start the discovery. That's why it's not opened. Unfortunately, Ansys Workbench doesn't show the geometry, the mesh which it creates during the process of creation. It shows only on the finish, but it creates the highlighting of the geometry which it mesh for the current moment, and for the most of the case during the creating of the mesh, Ansys use a whole number of cores which they can find, and one object per one core. So if you have, for example, as me, the 6-core processor, and if you have enough of slots in the license, it will use any core for creating the mesh which they found. Not the virtual core, not the threads, but the physical core from the processor. So I have the 6 cores. In most cases, Ansys will use with the default license the 4 cores only, and for additional cores you need an HPC pack. I have the one, so I can use for the 12 number of cores. It's 4 cores plus 8, but I doesn't have 12 cores, so something like that. So and in parallel, I need to answer to my student, to my current student, because they work with their thesis, with bachelor thesis and the master thesis. So no one is watching, no one is present, and no one wants to make conversation chat. That's bad, but it's a lack of small channels. So as you can see, it's almost 90% had done, and very soon we will see the result of mesh. And where my discovery, I had started it by the second time, and at that moment I started it truly. Maybe it's in the reason that we create mesh and it doesn't found the license. If you will try to repeat it with the Ansys student edition, you will have the big difference even with importing this geometry. So maybe it's will be more interesting and more correct way to you to take a part of this construction and simplify this model with some other CAD software which have the educational, if you're a student or educator, or personal for hobby type of the license, or use the software which you have with the full license, and you can simplify this object. You can lift about 10 to 20 objects to repeat this work part by part, and it sometimes even can be more efficient way to do something like that and to work with the big objects. If you have the original CAD data, CAD data, then maybe it's more helpful way to not import the full assembly as one file, but import some sub-assemblies as a separate objects here, and then create the mesh assembly inside of the Ansys. It also can be done. So, oh, yep, this is our discovery. We simply need to wait. Okay. And where is my model? Design 1. It looks like it's not open, it's not import. Our object. Okay, let's repeat. Let's wait till it finishes the loading of the mesh result, because it's already meshed. And then we will open the model. Unfortunately, I think it can work with the parallel processes because I have the license for CFD and for mechanical, and I use a different type of license for discovery and for mechanical task for working in parallel, but unfortunately it looked like it have some problems and some locking. If you are present on a stream, please write a comment and give information. Even if you're not interested in this type of content, please write to me a comment. Do I have a sound? Because I even doesn't know that. Did you hear me? Did you see me? So the meshing, automatic meshing is done. We need a couple moments. The main problem with the big objects is time to wait. And mostly it's the main difference between the different object, different CA systems. And sometimes it's very important because some program even can't do something like that. Oh, I have the problem with OpenGL driver. Even for him it was bad enough. So I think we need less fine mesh, but I can say that some of this object, for example this one, look like it meshed with the hexa already. So it's more simple situation. It looked like something fall. It looked like mechanical is falling down. London Bridge is falling down, falling down, falling down. This is a real process. Sometimes even very expensive software is falling, and not always it's a problem of the software. Sometimes it's a problem of the user and operator. So it's very interesting. Do we have the mesh for now or not? Unable to view geometry, unable to get the model. It looks like we have the big problem. Okay, let's open it here. For another one, type. So the fucker was drunk and nothing was happened. The fucker was drunk and the trick failed. Yep. The trick is failed. So we lose the geometry. During those opening and closing operation, Ansys lost the geometry. Or no? Nope. Not lost. That's good. We simply must wait. That's good. That's much better. I think it was 300 of body, but it writes that it's only 100 of bodies. Okay, 100 and 100. So this is our object in a discovery, and we will do the most operation here. So let's renew our operation. Unfortunately, the mesh will be lost even if it's created, because during opening the model from the model by the discovery, we change the ID of the parts, the ID of faces, and so on. I have the video about this on the channel. And firstly, we import from the XT file. You can open from the step file, but if you know that you will need to do some changes with the discovery or with the space claim, please not the import in Ansys Mechanical the step file and then open in discovery and do some changes. Import those file, open with the discovery, and only after that open the Ansys Mechanical. Because with those type of the process, with those type of workflow, when you firstly open in discovery or space claim and then open in the Ansys Mechanical, you will have the same ID already, because in the previous variant of workflow, when we firstly open the step or parasolid model in Ansys Mechanical, they get the ID of the objects from the parasolid or step file, from the nature file, from your CAD file. But when you then open in Discovery or SpaceClaim, or even with Design Modeler, it changes those IDs, and everything which you prepare what you prepare in the Ansys Mechanical will be lost. For this moment, Ansys Mechanical have very good tooling and give a lot of possibilities to renew lost data. So if you simply open geometry first in Ansys Mechanical, create some mesh properties, create some boundary conditions, and applying some materials and so on, then when you import it in Discovery and renew your geometry, even with all this lost data, Ansys Discovery have some intellectual algorithms to find bodies and faces which is corresponding to them. And what's happened? Not only my brain doesn't want to work today, but it looks like Ansys also have some problems. So this is Discovery, this is Sys, it's very important. So this is the system of Ansys. Yep, I want to reread all data. Please. I know it's very slow, but the real engineering process sometimes look like this. What the hell happening? The Ansys is broken. Okay. Okay. It's not good. But we can do some fixes of this process. So we now create the new object. It doesn't have connection through the model, but it has connection through the geometry. Let's take a look. Maybe the new object will be work without those error. If we will have this error again, we need to restart Ansys Workbench and to create the new model. So, now it's important. That's better. But I doesn't see outline. Let's wait. Let's wait. I don't want to restart the workbench. It will be yet another time of waiting and wasting. But that's why it's called the live process. Unfortunately, it has some effects. Yep, the outline is present. Okay, that's good. So we don't need to restart the Ansys workbench. Or need. Yep, at present. Yep, this is our model. It looks the same because the geometry is the same, but it has some difference. Okay, so now let's start additional discovery and additional Ansys mechanical. And because we... Thank you, Leonid. And because we have some limitations with license, maybe we will have some problem in parallel, but in most cases we can solve two cases in parallel, and we can't use the Ansys mechanical preprocessor or post-processor during the solution, but we can work with the multi-preprocessor window, because in any moment we will work with only the one window. So I hope it will be enough with my type of license. Leonid, if you are present on stream, please write, did you hear something? Did the video is smooth? So we open a new discovery, and it's, for example, for this purpose. Let's take, for example, this object. Something like that. And now let's copy, Ctrl-C, Ctrl-V, paste this geometry to work with the less number of objects. Yep, that's good. I don't think that my voice is the perfect, but thank you for the compliment. Okay. So this is our object, and it's have less details, have less number of parts, so it will be meshed much faster and work much faster. So let's return here and let's open the model. Good in sound, yep. Thanks. So the comments are present, but my faces hide some of the comments. It will rise due to the time and new comments, but let's work. So if you see the same type of error about JavaScript and so on during the first running of the new Ansys mechanical video, in most cases it's came from the process which you need to delete some old files, some old junk files from the previous Ansys version, and you can find the workflow of this process on Ansys forum. But unfortunately, in my case, it doesn't help in some reason. I don't know why. Because I doesn't have any old Ansys version, and I delete all those folders, and unfortunately this error became in reason of renewing the license, and I have the license from the Ansys partner, Ukrainian Ansys partner called Soft Engineering, but for this moment I have not the license for 1 year, but the license for 1 month, and I need to renew it plus minus every month. And after renewing of this license, I have this type of error every time. So I left this process because I don't know why it's happened. So yet I don't see anything. So we have the smaller object. Let's mesh it. We can see that the default mesh now not present here for some reason, the size of the default mesh. But let's also create. It will must to be much more faster. So we will not stop on the automatic mesh. We will try to create the hexa-core mesh, and we will do it by the hand. But we need to understand what they can do by automatic. So this is our mesh, and if we use the second order type of elements, if we work with the general static stress, if we doesn't talk about the behavior of some joints, behavior of some small parts, it's good enough. Yep, it's it's not good. It's really not good, but it will produce some general deformation with maybe adequate type of the accuracy. Not the stress, not the local stress, only we can talk about the general stress, but something it can produce. Also, you can see that some of this object, which is very simple, already meshed with the hexa-core, and that's good. Maybe those mesh need to be refined, but it's already hexa-core, so it's good. So let's check. Let's take this object, which is similar, but as you can see, are not meshed in a similar way. So hide all other bodies, and let's take a look why it's so. And we can see that it have some additional elements here, which give no possibility to mesh this object with hexa-core elements. Additionally, we need to say that even this small task have already 82,000 of elements and 160,000 of elements. So it means not this part, but all this subassembly. So it gives very highly detailed mesh with a lot of elements, and unfortunately it will create a problem for calculation, and we have that with the rough mesh. And as you can see, we have not very good quality mesh, with some small sizes, with some big sizes, especially here. And we have some elements which is meshed in reason of the size with small side, but those type of mesh create a lot of local nodes and elements, so that's why we have those problems. Let's try to change the type of the mesh for this object, for only this object, and let's take a look to the result. We will suppress all other bodies, so we suppress all other bodies, and now we can see that we have only 1,500 of nodes and 800 of elements. And now let's work with them. So if we select the mesh object at outline tree, at the project outline tree, we can get access to the different type of mesh tool with the context ribbon tab. This context ribbon tab change the tools depending on the object which we select on the outline tree, and all other are not context dependent. So we need this one, and it's very good because we have the big amazing icons, which is very similar to find, which is very simple to find, sorry, and so on. So first of all, let's try to create some changes in methods. We select the method, we select the body. First of all, we will not try to use automatic way, because this is the automatic way. Those mesh which we already have, it's automatic. So let's change this to the tetrahedron. For this moment, we will see the same type of mesh in most cases, with the same type of elements and so on, because this is our tetrahedron mesh. And as you can see, yep, 800 of elements and 1600 of nodes, and mesh look the same. This is patch conforming method, and in the next releases you will not have the variants of patch conforming and patch independent methods. It will all be tetrahedrons, and depending on additional tools which we use, it will change the type of the mesh. But for now, and for previous version of the Ansys, we can find here the preference patch conforming and patch independent. Patch conforming is when we use the wall geometry, wall number of faces, edges, vertices, and so on, to creating the detailed mesh. And if we change the patch conforming to patch independent, we can say that we can have the smallest element, and for example it must be, just a moment, this is about 1.5 millimeters, and okay, the distance, we can't measure here the distance by those ways, so it's about 0.2 millimeters, something like that. So let's say that we want to have 0.5 millimeters of our minimal size of the element, and it tried to create defeaturing. And for example, this step, this face can be defeatured, here can create defeaturing some, and we will have the same tetrahedron mesh with some changes and with a less number of the elements and nodes. It's not always good, but for general stress it's very important. This type of mesh creating longer than patch conforming method. And nope, it not create any type of simplification. Okay, let's add some addition where it's defeaturing. Mesh defeaturing off. Let's take it on. So defeaturing size 0.5, the same, and let's generate. The other type of creating mesh, like sweep, will not work here, because from this point to this point, yep, we can create sweep mesh. From this point to this point, we also can create sweep mesh. Also, for some reason, we can create a sweep mesh by hand here and here. And with the creating mesh from our hand, we can create the mesh from one side to another by our hand. But unfortunately, it must be done with our hand. And as you can see here, we have some defeaturing, and this H are not present. and it try to merge here objects. If we increase the size of our defeaturing, it will create mesh even more smoother here, not smooth. But in most cases, for now, this option are not working. Very interesting option, we can also change here the proximity and curvature. For example, we can say that no, and we will obtain a mesh not about 100 of 1000 of elements, but less in a size. Something like that. And as you can see, it defeature here very create very forced defeature, and it create very bad element quality. We will not check element quality for now, but even without checking all the element quality, we can say that it's not good here. But as you can see, we have 500 of elements and 1000 of elements, so it's less than on a first attempt with automatic mesh. So let's change this tetrahedron to the multi-zone variant, and I bet it will not work, but I don't know, because Ansys put a lot of money to improving this multi-zone method for every version, and every time it's worked better and better. But unfortunately, nope, it not. Maybe with some additional information by hand, it will work. But unfortunately, for now, it's not working. So, a very interesting type of creating hexa-core element is Cartesian. But in most cases, for the rounded object, it creates very bad type of mesh. No, it's even... I didn't expect that. It's very interesting. Okay. Default element size, let's make something about 1 millimeter. I didn't expect that. Oh, that's better. That's type of the mesh which I expect. And as you can see, it's hexa-core, but here it's not very bad. Here it can be the under the question, but in reasons that we have here this geometry, it's not very bad. Type of creating mesh, but the quality of those elements, of this element and of this element, as you can see, are not perfect, something like that. Yep, it's very nice suppression. It's when we talk about creating the full number of cubes, as I understand. So let's do it by our hand. We open this geometry. We open this object. Components, open component. So this is our object. And let's do some split. What about element inside? I don't want to take a look elements inside of this mesh, but in most cases, the mesh elements will be look like this because the type of the Descartes mesh, Cartesian mesh, creates the fully quadratic, fully hexa mesh, and then try to move the edges, move the nodes, and so on to the nearest border of the geometry. So if we take a look, for example, here, it will not very bad, as you can see. And yep, I forgot about one option. It's also present in variance. It's not Cartesian, it's mean hex dominant. And hex dominant creates very, very dangerous situation. It creates the variant which look sometimes even perfect, but when you didn't look inside. So for now it's not perfect, but as you can see, mostly it's like the quad mesh, mostly it's hexa mesh. And if we create the section view, we will see that in some places we have very strange tetrahedral and hexahedral mesh, and even for the simple hexahedral object like the cube, the hex dominant mesh will create inside of this cube very strange mesh because of the method how it create. Because firstly it create in most cases. It can work by two main type. First approaches create the tetrahedral mesh and then split those elements or unite different elements in the hexa and then create some smoothing for obtaining better elements. That's the first approach. And the second approach is when we take our mesh, our object, we create the quad mesh on the boundaries, on boundary faces, and then we extrude this fine mesh inside of the geometry and fill all the gap with any elements which we can obtain. So it can look like perfect, but inside it will look very ugly. But if you doesn't know how it works, sometimes it's perfect. For example, if we here will create something like, I don't know, let's add some mesh size, for example, here, and let's say something like a 0.5 millimeters. I think it will create much finer mesh in the general look. Yep. When you had study, it was a general situation. So, as you can see, it looks much better, and even those type of meshes are not very common, as you can see, and sometimes you can even obtain the mesh which look very clean even without those type of the elements. But inside, if we take a look inside, we can see that it's not perfect. It's very not perfect. Especially in the place when we have some difficulties with geometry. In places where we doesn't have any difficulties, even here we have some strange waves. But in all other places, it look like, I don't want to say this word. And hexa-core mesh, which we create with the hex dominant mesh, doesn't produce only the hex mesh. It also produce the prism, like this one, like this one. It also produce the tetra and the pyramid. So you can check the mesh quality, and you can see that we have all type of the elements. The tetra and the hexa, it's most of them, and as you can see, those is good hexa. It's most of our construction, and especially near the boundaries. And this is also near the boundaries, and it's not bad hexa. But we have the tetras, we have the theoretically it's wedge, but by color I think I select the pyramid. So it's difficult to select here, but you can see the different type of elements, and everything here it's bad enough. And the main advantage of this approach is that we create the mesh which near the boundary look like very good and high quality, and in some insides it have bad elements, but it's not sometimes important, because most of the mesh concentration, because most of the problem we will have with on the construction on the boundary side, on boundary faces. But you need to understand that those type of the bad mesh produce sometimes very wrong result of behavior in those places, and you can obtain the good result on the boundary faces. And all type of checking will say that it's very good result, it's very accurate result, but in result of this internal, let's call it, okay, I don't want to call it, I don't want YouTube to ban me. So in reason of this element, you can in some places obtain not very accurate result, which are not coming from the real physics behavior, but from the mathematical errors of the modeling. I suppose we need to take electrosaw and slide this model a bit. Yep, we need to model, we need to slice it. That's why we start that stream. So, what should we do? We can solve this problem in a couple ways. the first way which we can use to create the ideal hexa-core element, it will be enough to split body with those face sorry, it needs some time, and with the control we select other face here. So we create 3 body. Even we don't slice here because it's enough. And now when we update our geometry, we need to return here. And when we update this geometry, we obtain the part which divided to 3 body. And in some reason, we obtain not the part which consists from the 3 body. We obtain 3 different parts. And during the geometry, it's body color, so every different color, it's different type of object. So, why I say that this is some type of solution? Because it lost some information about material because we create the new geometry. This is our old geometry. Go to corresponding bodies and tree. Nope, this is old. Yeah, I don't remember which color it was. I'm not the color blind, but yeah, it was the gray one. So this 2 new body doesn't have any material properties, as you can see, and it's not a problem. It's only highlights that we have new bodies. It's not important for now that they doesn't have the material, because we will not do any solution. We only create a mesh and we applied material later. So it's not important, and we will not take a look to this problem later. Now we can delete this hex dominant and this body sizing, and we can create the mesh, automatic mesh, and we obtain the hexa-core mesh. I hope. So we obtain mesh hexa here, we obtain mesh hexa here, as you can see it's good enough, and we doesn't obtain mesh hexa here. It's created with tetra result, but only small numbers of tetra, and we can also change it. So we select this object, we apply the method which don't work on the previous stage, it's multi-zone, and I think it must do his job. Yeah, as you can see, it creates a good hexa-core mesh. And as you can see here, we have fully hexa-core mesh on this model. There are no tetra, there are no wedge, there are no prism, pyramids, and so on. Only hexa. And even it's not very bad. This is have some problem. Not a problem. We will talk about this later. So everything look fine. Yep, I'm cheater. Why I'm cheater? Because we have 3 body. So we have the connection here, which glued one body to another. And we have 2 connection. And it can be viewed and checked by this behavior. So as you can see, the mesh, even if it look from this distance as something very, very similar, for example here, if we take a look closer, we can see that nope, it's not, that this mesh doesn't contain here. It's two very different meshes. And the reason why we have the nodes which is closed here, that's because these cylindrical faces is the same like these cylindrical faces. And here we also have the same problem. So unfortunately it's not so good. So how we can solve it? We can solve it in two ways. First of all, we open this geometry, we return here, we select prepare, and we have a tool for sharing the geometry. I know that this tool works very different on the latest Ansys version and on the previous version. It works very different on Space Claim and on Discovery for now. And from my point of view, more affordable, more good way to work with the shared topology present on the previous Ansys version and on Space Claim. Maybe because I don't know how to work with those tool and doesn't have enough experience for now. But this tool create a shared topology it's look the same, but as you can see, it creates some different slices. Here, that element was not present, and here. Why it's not coming from this edge, I can say. In most cases, it must be with those edge. But now we create the one part, and here this part will present now with those type of icon which show that this is the object which created with shared topology. And now when we update our object, it also will be with 3 different colors because it's a different part. But if we select here the geometry, first of all, we can see that it's this wall geometry is one level list. And those two objects and those objects, so those 3 objects, are present in the list in different places, and that's all. And also, if we change here in details the display style for our geometry from the body color to the part color, now before we update the changing of geometry, it have also 3 different colors, the same colors as body for this moment. And when we update our geometry by right mouse button, it will say that some objects are not unmodified. But as you can see now, all these three objects have one color. As you can see, all these three objects present in the list inside of the name of the part. And as you can see, when we change here from part color to the body color, it will three different colors. So that's the way how we can understand that our objects are have the different parts or have the same parts. So additionally, as you can see, the reason why it's split here came from this one. So it's not only imprint, it make some additional changes to look like this one. It's not very good, and as you can see in some imprints it look the same, but it's how it try to work. So it's try to minimize work for us. And if we create mesh for now, we will have some problem. Yep, in general, it doesn't create any mesh. Let's suppress this object and let's create the mesh. And the mesh looks like this one. And if we are not interested in those places, for some reason, we doesn't have here the contact and so on. It's not very bad, even with those objects are not the hexa. And as you can see, we have the hexa-core, tetra, and the pyramid. Pyramid will came from this hex element to one node, and here from this element to one node, and between those pyramids everything is tetra. And if we create the split tool, we will see that our mesh look like something like that. Can we create the mesh multi-body here? For this moment, maybe not, but sometimes it can be created with some additional preferences, and you can obtain the hexa-core mesh. But those type of behavior are very bad because it's changed dramatically our geometry, and inside of our geometry, when we talk about this object, we have inside here also a contact and so on, and it will produce a lot of errors in the nearest future. So we return to our model, we select our prepare tab, we unshare all topology, and we return to our design. Now we also use split. Now we use the split those geometry with those type of face, and we create two objects. And also we use with control, we select those face and those face. We select those face and those face. And as you can see, we select everything. Almost everything. Because here we have the same situation. And maybe it will not take these vertices to this place here. But let's return by Ctrl Z to the split body operation, and with Ctrl select our cylindrical face to create additional split, as you can see. And now we have the fully splitted geometry, which will be meshed in a simple way with hexa-core. This triangular object, which is prism, can produce some prism elements, wedge elements, but in most cases, if we will not produce only one element per side, we can obtain here the hexa element with good quality. Because if we have here nodes and we create here nodes, we also will have the hexa object. But this hexa object will be very curved in some point of way. So better if we have this possibility to create not the one elements per side, but two elements per side. In those variant, it will create mesh like this one, and those type of mesh will have better quality than the previous one. So let's return here. We firstly need to return in Discovery to the main object, because if we don't do that, we will have the problem with updating geometry. And also, while I talking, I forgot to do the sharing topology option. Now, when I say that it worked not very well, and you see that I only push the button that everything is good, it looks like it works like it must, but unfortunately it's not. So maybe we will return to this later. So now we have possibility to update those geometry. We will have much more parts. And I can see that I split not everything. Yep, in some reason I split not everything. Okay, that's the standard situation. Yep, I forgot. So prepare, unshare. It's better to unshare and then share than to edit geometry. Now we need to do some additional splits. Let's select something like that one. And let's split with those face and with control with those face. Did I split everything? Now it looks like everything. So share topology. Return to the previous geometry and update our geometry here. And I not returned had returned to the previous geometry in reason of shared topology, and we obtain the error. Update geometry. So as you can see, we have here much more objects, and everything is splitting. Let's check that all these objects are one property. Yep, it's the one. And now we can delete this multi-zone because we don't need, and we can simply generate the mesh. And try to minimize the number of elements, so it creates something like that. We have the hexa-core elements here, and we have the non-hexa elements for all other type of objects. So okay, let's select, let's do some another thing. So we select, for example, this edge on the cylindrical face. We select on the top selection and create selection. And during creating selection, we select the size. So we select not only the one edge, but for this moment, we select all edges which are similar to this one by the size. And now we have the two edges, which is very short. One edge is 0.5 millimeter, and the second 0.2, 0.26, if we will say it clearly. So I want to change this selector from the equal to less than or equal, generate, and it will select a lot of different edges, as you can see. All edges on top here, all edges on the bottom, and all edges inside, but it also selects these two edges. So I add here one row, say that I want to select edges, which are greater than and 0.5, half a millimeter. Not greater or equal, but greater. Select. I'm sorry. I need to remove, not add. Generate. That's a problem. Okay, let's do the range. I don't remember 2.8 with the 2.9, let's say, and here we will say 0.5. So this will be removed. And yep, from 0.5 to 2.9 in opposite direction. And as you can see, we select everything but something like that. Okay, now that's good. And for all these edges, we create in a mesh sizing. Select here not geometry but name a selection, and select this first selection. Better it's to give some names, but for now it's not very important. And we change the element size to the number of division, and let's say 2. 2 as number of division. And also we can select the edges. We will do those selection by another type. We will not came here to selection to this creation, but select here size, and here we have the elements larger than selection. Just a moment, maybe this one. Okay, let's do like this. And we create the new mesh sizing, where we say that we need the 1 millimeter size. It will create by geometry selection, not by the named selection, and we generate the mesh. And almost good. This one have not bad element. This is not ideal, but okay. And those objects, unfortunately, have some problems. Okay. Clear generated data on selected bodies. Clear generated data on selected bodies. Hide this body. And that's why you can see we have some problem, because those objects have not the quadratic meshes. Okay, let's hide those objects. And we have the same problem. So this object doesn't mesh properly. These objects also doesn't mesh properly. So let's select this object and create face meshing. Also, even if we select one object, we can click here and then add additional faces. So now those objects lose their mesh, and we can select this object, generate mesh on selected body. Better, but not good. Mapped mesh, yes. Multi-zone. We don't need here to multi-zone, but let's, okay. Let's try to do sizing, not sizing, sorry. Method here. And here. Maybe one this. Not automatic, but sweep. And not automatic sweep, but manual source. And as source, we select those face. Sizing. Let's try. Nope. Okay. Let's mesh from this side. And let's create manual source and target. For simplification, generate mesh. Okay. Is it one different body with different mesh or different body with one mesh? It's I don't get your question, Leonid, unfortunately. Can you describe it more? With more words, with more detail. So, okay, maybe not sweep. Let's try to multi-zone. Can do. Okay, it's sometimes also present. Let's do it in another way. Clear generated data. For wall mesh, and now create something like that. Select, generate mesh. No. Clear generated data. Sorry. Misclick. Select generate mesh for the current on selected bodies. No, we don't need to create gluing connection, because when we create a multi-body part, it created with the different bodies, but it's a one part, and on the shared topology, on the shared edges, on the shared faces, we have the same nodes. for both body, for one body and for another body inside one part. That's why it doesn't want to create a good mesh inside of this object. So sometimes it can be tricky. And pam pam pam. So face meshing. Sometimes it can be tricky. Generate unselected body. Only unselected, please. No, you can't. Multi-zone method. What did you say? Free mesh type. Not allowed. No, I don't want to allow the free mesh type. Okay. Generate preview surface mesh. Show all bodies. Okay, let's came from another side. Preview mesh unselected body. Don't want, yep. Face meshing. Preview surface mesh. That's better. That's better, but not good. Oh, sometimes it's more simple way to... Could we check if existing meshes have the same number of nodes? Maybe it can sweep. It can sweep. It contains the same number of vertices and edges, and it have the same numbers of these cases, but it don't want. We can solve it in a simple way. We can don't share topology. We can create the same mesh for the couple of bodies and then merge the nodes. It will be a most simple way, but I don't want to go by this way, unfortunately. So just a moment. We can... Okay. Yep. Okay. Hide this one. Hide body. hide body, pull, extrude this face, and nope, it will, and unfortunately it will not. Okay, it will create the free mesh. Let's do like something like this one. And now it won't work. Okay. Dumb Ansys. Maybe it's a more simple way to unshare topology, because the time is also needs to be done. Okay, so we returned here. Unfortunately, in reasons that those bodies inside connected to other bodies from all their side, it doesn't want to create the hexa mesh even when it can. So if we, for example, hide other, if we select only this object, we'll see that it's simply hexa, and it can be hexed mesh. But unfortunately, in reasons that this object surrounded by other object, it doesn't want. The only one way which we can here solve this problem is to change the mesh type for the wall object to the hex dominant. I don't want to do that in fully automatic way, because it's not very good situation. Let's start first of all the hexa, maybe multi-zone, maybe it work. No, it won't. So multi-hexa, change to the hex dominant, and now I think it will create the hexa-core mesh. But inside of this object, some of this mesh can be strange. That's why I don't like this type of hex dominant. As you can see, it splits first of all to triangles, then it converts triangles to quad, and can do it not very fast, depending on them. And as you can see, it looked like this. And the main problem that it ignores our preferences of behavior. Let's do it hard way. It's not often change anything. Now, unfortunately, in Ansys Workbench we have this pull tool. It's like sweep, but it works only in the hand way, and it's can't be for the geometry, it can be for creating the new object. but automatic sweep variance I already tried to imply, and it's not work, unfortunately. So we need to create or the hexa-core mesh and hope it will be fine. Yeah. Here we have the normal object, here we have something like, but we have the wave here, and here we have not the best split. Let's take a look inside. And inside we have the hexa, but with those type of problem. It can be solved. This problem can be solved very simple way. So let's delete those type of face meshing and let's create another one. So we create the new face meshing, we select the face and we select here method not by clicking but by box selection. And we select something like everything. Every single face must be fully quadratical and mapped mesh. Let's generate. I hope Ansys solved this bug with the body which is surrounded by others. But unfortunately, they are not. As you can see, we have the full hexa object, and we have only two element quality. We have the main objects, as you can see, and we have those objects, as you can see. And all this hexa-core mesh, even it was created with the hex dominant mesh, are almost perfect. But as you can see, this type of the icon says that we have some problems with applying face meshing control. But as you can see, it's almost the ideal. And unfortunately, I say that we have only two type of. No, we have not only two. That's another. That's another. That's another. And that's the main problematic geometry. But I don't see problem here because it's second order elements. So for me, this mesh have a very good variant of meshing. So something like that. And now we can see the statistic of our objects, and we can see that the number of elements are almost the same as it was on the very beginning with fully automated triangular tetrahedral mesh. And it was 800 of elements, and now it's 980, so it's almost the same, 20% plus, but the number of nodes changed dramatically from 1.5, 1600 to 5700 elements of mesh. But as you can see, the mesh it's quite looking good. Here we can produce lower number of elements. For example, during the lengths, so we can create mesh for this object and create mesh for these objects. So we can do something like, just a moment, when we selection the single mode, select this one, select size which is equal, say apply, and select this, this one, maybe this, and 7.5, something like that. Sizing, and we create the sizing element 2 millimeters, for example. The mesh will be not so fine with the quality. But the number of elements and nodes are decreased. And now we have not a tetrahedral mesh with one element per this thickness as we have on the very beginning, but we have elements with two objects with two elements on the thickness, so it's good mesh for any type of thinking. The last things which I want to show here. So we return to the discovery and we unshare all geometry. So return to this, return to this, update our geometry, and you can see that we have a lot of objects with question which are not inside of this. One object is the same and a lot of objects with different colors. Some of colors sometimes are corresponding, but it's different bodies. So now we can create the new set of preferences. The face meshing we don't need. And also we can select all these objects and say that we need to apply the sweep method for all these objects. Generate mesh. And we will have the same number of elements, almost the same, and much bigger number of nodes, because some of these nodes will be twice. Okay, this object won't okay, it's no matter. Let's return to this object. Oh, hide laser. Sorry, I have some problem. Oh, yep. It left those type of splitting on the geometry. Okay, it's not a problem. We can solve it. So if we will do this without all these changes, it will be swept. But for now we have this type of problem. But it's not a problem because we can select the project, we can model, and we can create the virtual topology, and we can select those type of faces, create virtual face, and maybe even we can also add it here and generate the mesh. Oh. Yep. So, show all. As you can see, we have this number of nodes and elements. Unfortunately, on some places, it ignores our edge sizing. So we need to select this edge sizing and say that it's hard behavior. Sometimes it's produce more controlled way, mesh in more controlled way. Sometimes not. Okay, just a moment, name and selection. Oh, and then it forgot some objects. Yes, it forgot. Okay, just a moment. So it's just a moment. Let's select. Let's select all these objects. And create mesh sizing, and let's select all these objects. And let's create the sizing. And for both of these objects, we create not element size, but number of division. For the same behavior, So something like that. But what's the problem? The problem is that when we try to select, for example, here the nodes, we select two nodes, as you can see, and one of this node, just a moment, we select two node, and one of this node it's this, and the second this. And if we try to select here the node, we select the 3 node because it looks the same, but one node are connected only to one body. And because we have here 3 different bodies with 3 different colors, we have here 3 different nodes. In some places, if we select in right manner, we will even have much more nodes, but it's hard enough to select this. So we have those contacts which are trying to glue this model, and I don't want all these contacts, so we will delete them or even suppress. So, and what shall we do to obtain the one node for anybody? On the mesh toolbar, we have the node merge object, which is mesh editing also. So we create the node merge. We need to select what type of geometry is the main, the main, it's those object is to create between two bodies which we select by hand, and when we create the node merge, the same like we work with the contact, we can select it for the number of bodies, and for example for whole number of bodies. And in reason that we have here the nodes which are which are on the same position, we can input very small distance to merge all bodies. And now we need to detect connections. It creates node merge for everybody, body to body. And now we generate and we merge almost 1000 of nodes. So if we take a look here, we will see the same numbers as we see in the previous version. So it's not 4000, it's 3000. And now if we try to select the node on that place, it selects only the one node. So this additional type, and as you can see it's much more simpler way to create the fine mesh. We not split those objects. We not split those objects into the fully splitted, and also it also can be the problem of creating sweep body. I don't think it's for the beginning, but it also can be a problem. So let's check the last one and we will stop the stream because it takes a lot of time to create the mesh only for one body. And if you are interested in, we will create the mesh body for other bodies as well, but on another stream. If you like those type of content, please write a comment. So, we return to our discovery. We return here, show all geometry. Select those type of object. And that's the problem which we see. So it's the one body, but one of his faces are split. So we split this body with those face, with those face, with those face, and with those. And now we have the 5 body here. Okay. Show all. And the same, hide all other. Split body. Show all. Prepare. Shadow topology. And here it shows that some of these edges have connected to 3 different bodies. It's showed by yellow. So, we return here. We update geometry. And even if we doesn't obtain the good results, this will be the finish of our current stream. This is the tool about which we talked on the beginning. It tried to find the similar elements to create everything. We don't need the mesh edit. Just a moment. And let's create our mesh. And we obtain fully hexa-core mesh. So it's not the dump Ansys, so it's dump user. Okay, so this is how it works on the one object. And if you like, we will talk later about all these objects, maybe with less number of comments, simply the work. And we will try to obtain it here. And what I want and need to show you. So if we open this object on original system, it will be not split because we split it not here, but on the different task. And the problem is that on the full model, we have the number of this axle, it present here. Let's hide some objects. It present here. It present from the other side. This is our object. And as you can see, it's not splitted in any places. And it's also present here on the rear side. And it's also not splitted. So what shall we do with the big model to apply all our work which we do previously? We can open this object and split it by our hands yet another one time, but it's not very comfortable, so I want to open this one object, return to our another discovery where we split it, and I want to do something like this. I select everything, I Ctrl-C it, and return here. Let's change this name to more simple way to find it. And we put all the splitted object here. And as you can see, it came here. And the first object is our not splitted object. Now let's return to our main assembly. And as you can see on the rear side, it's splitted. On the left side or right side, it's right side, it's splitted. Not only at the place where we actually take it and split it. Why? Because it's the same object, it's the same part which are present couple times in this assembly. So we can do the same workflow with all other objects, we can simply split and simplify the one part, and then we can change this part with the splitted one, and that's how we obtain the good mesh for everything. So thank you, and write a comment if it was interesting to you, and also you can support the channel with one of this QR code. It will be very helpful. Thanks and bye.